Hello everyone, welcome to today's class. We're just going to be doing a few things around sort, simplification, and addition and subtraction of sort. Welcome again. Alright, what is sort? Sort is the square root of imperfect squares. What are imperfect squares? Imperfect squares are numbers that do not have a perfect root. Okay, like there is no whole number you can multiply with itself that will produce those numbers. So those set of numbers are imperfect squares. So when you look for their square root, their square root is always in sort. So numbers whose roots cannot produce a whole number, they are called imperfect squares. Okay, e.g. root 50, root 80, root 120, and so on. So next we have perfect square or perfect roots. Okay, so examples of perfect squares are 4. Okay, you get 4 by multiplying 2 by 2. Next is 9. You get 9 by multiplying 3 by 3. 16 by multiplying 4 by 4. 25 by multiplying 5 by 5. Let's demarcate here. So you have root 4 here. When you simplify root 4, you will have 2. When you simplify root 9, you will have 3. When you simplify root 16, you will have 4. And when you simplify the square root of 25, you will have 5. So when I mean roots or square roots, they are the same thing. When I say root or square roots, they are the same thing. Okay, we'll continue by taking a closer look at perfect squares of numbers. So when you multiply 1 by 1, you have 1. When you multiply 2 by 2, you have 4. Just like I said in the previous page, 3 by 3, you have 9. And 4 by 4, you have 16. 5 by 5, 25. 6 by 6, 36. Then 14 here. You remember then in our primary school, we used to have multiplication table. Okay, multiplication 1, 2, to probably 12 or 20. Now I want to create a new multiplication table. So you call it multiplication table of squares. So what do you do there? Just multiply a number by itself. Like 1 times 1, 1, 2 times 2, 4, 3 times 3, 9, 4 times 4, 16, 5 times 5, 25. You understand? I would do it then in a primary school and we dance. Okay, but this time around you don't need to dance. Okay, you've grown up. So please try and know the squares of number from the square of 1 to the square of 20 minimum. You can know more, but I'm charging you know from 1 to 20. Okay, you can make a reading if that will help you, but don't dance. Okay, so we have the other part of the page for root of numbers. So for root or square root of 1, we have 1. Root and square root of 4, we have 4. Root and square root of square root of 9, we have 3. For 16, we have 4. For 25, we have 5, and on like that. Okay, so you discover that the sets of numbers we have here are the same set of numbers we have here. Okay, now there is a need for emphasizing on these numbers because we're actually going to need them in simplification of our sort. Okay, these numbers are very important, so we're not going to be making use of them in simplification of sorts. If our time, we'll be making a list of them and writing them out. Okay, so you notice that they are the same set of numbers. Alright, we'll take a few examples. Okay, so we're going to be taking a look at how to simplify root 60, how to simplify root 75, root 250, root 320, root 1000. Okay, so let's see. Now, 60. I want to simplify root 60. How do we do that? We'll first make a list of these numbers. Remember those numbers I showed you the other time? Is that you call them perfect squares or perfect roots. Okay, it depends on how you use them. Now, the first thing you do is make a list of this. Now, from this list of numbers, you come here and choose any of these that is a factor of 60.
There is a reason I'm taking it slowly, is so that you can understand.
You come here and pick any of these numbers that is a factor of 60, and that is 4. Okay, now with that you express 60 as a product of 4. Okay, how are you going to express that? It means that what is the number you multiply with 4 that will give you 60, and then that's 15. Okay, so the next step is going to be 4 multiplied by 16. I've not done anything. I've only split 60 into 4 multiplied by 15. Why? 4 here, a factor of 60, is a perfect root, and that is what I want to get from that. Okay, I've colored my 4 in blue. Okay, why? When I find the square root of 4, I'm going to get a perfect number, which is 2. So what is root 4, or what is the square root of 4? The square root of 4 is 2. Okay, but look at 15. 15 is not a perfect root, so I can't do anything with 15. And again, there is no factor of 15 here, so I can split 15 further. Okay, and 15 also is not a perfect root. Hope that is understood. There's nothing else I can do by just writing out my final answer to be 2 root 15. 2 multiplied by root 15 is the same thing as 2 root 15. Please get that. Get that. Don't worry, maybe you don't understand it very well now. You understand it in subsequent examples. Now, the second example, I want to simplify root 75. Just like I did the other time, I will come here to this list of numbers and pick any of them that happens to be a factor of 75. Are you seeing any of these numbers that happen to be a factor of 75? That is 25. 25 is a factor of 75. Okay, then what next? I will express 75 as a product of 25. Okay, by saying 25 multiplied by 3. If I multiply 25 by 3, I will have 75. So what I've just done is that I have only split 75, or express 75 as a product of 25 and 3. Next, I will split this root. Root 25 multiplied by 3 is the same as root 25 multiplied by root 3. Now, from root 25, I am able to get 5. When I simplify, root 25 is 5. So that's the essence of coming here and picking a factor of 75, whereby I can express 75 as a product of it. 5 now multiplied by root 3. Okay, that is, if I simplify this, I will have 5. And here, I can't do any simplification further. Why? 3 doesn't have any factor here, and 3 is not a perfect root. So, since it is lacking both properties, I can't do anything again with root 3. So the next thing I will do is say 5 root 3, and that's my final answer. Hope that is understood. Well, we'll still have more examples, because maybe you don't still understand. Now the next thing here is
square root of 250.
I want to pick
Factors of 250
among these numbers, and the number is 225. Okay, so I'm expressing 250 as product of 25 and 10. Okay, I'm expressing 250 as a product of 25 and 10. Now this can be further split into root 25 multiplied by root 10. Okay, now simplify root 25. Root 25 produces 5, then multiplied by root 10. I can't do any other thing with 10. Why? 10 has no factor here. Okay, so I can't split 10 into any of these numbers. Okay, 10 is not a perfect root, so there is nothing I can do with 10 anymore. Okay, so why won't I just write my answer and move on? So my answer here is 5 root 10. Hope that is understood. Okay, now here is root of 320. Now I come here and I look for a number that is a factor of 320, and that is 16. Multiplying 16 by 20, I will have 320. Root 16 multiplied by root 20. So from root 16, you know I'll be able to get 4. Yeah, I'll be able to get 4. So that's going to be root 16 multiplied by 20. Here still has a factor among this number. 20 has a factor among this number, and the factor is 4. So I can express 20 as a product of 4 and what? And 5. So that is 4 multiplied by 5. Is that understood? This time around, I'm having a number here. After I split the first number into 2, now I'm still having 20 that has a factor among this number. So that is why I'm having 16 multiplied by. Now I'm splitting 20 into 4 and 5. So making root 4 multiplied by root 5. Why? I will still get something tangible. I will still get a whole number from root 4. Understood? So I'm not just dividing, so I'm not just splitting 20 just for splitting sake, but from this factor 4, I'll be able to get a whole number. Is that understood? Okay. Now, so that's why I'll be having, from root 16, I'll be having 4, then multiplied by, from root 4, I'll be having 2, then multiplied by root 5. So now I can say 4 multiplied by 2, I have 8, then multiplied by root 5. So finally I'll be having 8 root 5. Okay, that is understood, right? The last example, root 1000. Having this list of numbers, what do? We'll pick any of them that happens to be the factor. 4 is a factor, 25 is a factor, any other one, 100 is a factor. So using any of them, you will still get your answer. Okay, but I will prefer choosing 100. Now I want to express 1000 as a product of 100. Okay, I want to express 1000 as a product of 100. That is going to give me 100 multiplied by 10. That is root 100 multiplied by root 10. Okay, now from root 100 I can get 10, and from root 10 is still 10. I can split 10 into any factor here. 10 has no factor here. 10 has no factor here. So I'm good to go. The final answer is 10, then root 10. So simplifying root 1000, I have 10 root 10. I hope that is understood. Alright, I'll be moving on to addition and subtraction. Please, I urge and spend a little time around this simplification, because we're going to apply them in this next session. Addition and subtraction. Okay, addition and subtraction of sort is done using the simplification method above, the one we've been using. So example, we want to simplify the following. We want to simplify root 8 plus root 18, root 27 minus root 12, and on and on. Okay, now we've got to sit tight. But if you know you don't understand the previous examples, please take your time, make sure you understand them. Okay, and also if you have any question, put it in the comments section. I will be there to attend to your question. Okay, and do not forget to subscribe to this channel. The subscription counts. Okay, and remember to like. Now we want to simplify root 8 plus root 18. Now I won't be taking us through the factors of all that. I won't be taking us through that. So by now we should be able to handle that. Now I can split root 8 into root 4 and root 2. Okay, root 8 can be split into root 4 and root 2. So here I'm having root 4 multiplied by 2 plus root 9 multiplied by 2. Root 18 is giving me root 9 multiplied by 2. Okay, so from that I'm splitting these into root 4 multiplied by root 2 plus I'm splitting this into root 9 multiplied by root 2. That understood? Root 4 gives 2 multiplied by root 2, then plus root 3 will give 3, then root 2. I believe that is understood. So this is 2 multiplied by root 2, and this is 3 multiplied by root 2. So 2 multiplied by root 2 is 2 root 2. 3 multiplied by root 2 is 3 root 2. Okay, I'm having two terms that has root 2 in common, so I can easily factorize root 2. Okay, so here I'm having 2 plus 3, and a common factor here is root 2. So I can have, pick this 2, then the addition sign between them and the 3, and I'm writing root 2 outside. Why? I'm having root 2 here, and I'm also having root 2 here. So if you understand factorization, you will actually understand what I've just done. And my final answer is going to be 2 added to 3, that's 5, then root 2. Hope that is understood. Okay, now here is root 27 minus root 12. So I'm splitting root 27 into root 3 and root 9. Okay, why? Remember, 9 is a perfect root. 9 is a perfect root. So I'm splitting 27 into root 9 and root 3, and I'm splitting 12 into root 4 and root 3. Okay, why? 4 is also a perfect root. So how do we go about that? Root 2 multiplied by 3, then minus root 4 multiplied by 3. Okay, so from here I can have 3, then root 3. I can have 3 from root 9, then I'm having root 3 here. So here I'm having 3 root 3 minus here I'm having from root 4, I'm having 2, then root 3. Now here again I'm having 2 terms that have root 3 in common. So the same way I factorize here, root 3 in common, so that's going to be 3 then minus 2 into a bracket, then root 3. So you open a bracket, 3 minus 2 root 3, okay, and 3 minus 2 gives 1 root 3. So when you say 1 root 3, you're actually saying 1 multiplied by root 3, okay, and 1 multiplied by anything, just anything, is that thing. It's not going to be 1. 1 multiplied by anything is that thing, not 2. All right, does that make sense? So that's why you're having 1 root 3 equals root 3. Now we come here, want to do root 44 plus 2 root 99 minus 3 root 11. Okay, so how do we do that? I'm giving 99 here special color, but there is a reason. You see now I'm splitting 44 into root 4 and root 11, then plus I'm splitting 99 into 9 and 11, and here I'm not just doing anything again. Okay, so this is 4 multiplied by 11, that is root 44, and this 2 here is down here, and the 3 here is down here. Okay, so I'm splitting root 4 multiplied by 11, I'm splitting it into root 4 multiplied by root 11, then plus here I'm splitting these into 2 multiplied by root 9 multiplied by root 11, then minus 3 root 11. I hope that is understood, please. Okay, here is 2. I got this 2 from the 2 here, so I'm putting a bracket in between here and here. So I'm splitting 2 root 99 into 2 multiplied by the root of 9 multiplied by 11. Split 99 into 11 and 9, or 9 and 11. Okay, so this I can get 2 from root 4, so that's going to be 2 root 11. Okay, 2 root 11, then plus here I have 2 multiplied by, from root 9 I can get 3, so that's going to be 2 multiplied by 3, then multiplied by root 11. Okay, so I got this 3 from root 9, this 2 is from here, the 2 here. Now this is root 11, then minus 3 root 11. Okay, now finally I'm still having 2 root 11 plus 2 multiplied by 3, that's 6. Okay, now I can multiply, that's 6 root 11, then minus 3 root 11. So I'm having 3 terms or 3 values that have root 11 in common. So the normal factorization, that's going to be 2 then plus 6 minus 3 all into root 11. Okay, 2 plus the 6 here minus 3. I've just factorized. Okay, so when I simplify my brackets, I will have 5 root 11. I hope that is understood. So the one before the last, I'm having 3 root 80 minus 5 root 20 plus 2 root 45. Okay, so just I want to be a bit slower here. Now I want to split 80 into a factor of perfect root. So I'm splitting 80 into 16 by 5, and I'm splitting 20 into 4 by 5, and I'm splitting 45 into 9 by 5. So just look at the matching of those blue colors. They are the figures or the root splits. So I'm going to be having 3 root 16 multiplied by root 5 minus 5 root 4 multiplied by root 5 plus 2 root 9 multiplied by root 5. Okay, so that's going to be 3 root 16 gives 4. Okay, root 16 is 4, then multiplied by root 5 minus, here is 5, root 4 is 2 multiplied by root 5, root 9 is 3 multiplied by root 5. So you can't get anything from root 5, you know that. Okay, so then I have 3 multiplied by 4, that's 12, root 5, 3 multiplied by 4 is 12, minus 5 multiplied by 2 is 10, and 2 multiplied by 3 is 6. Again, don't be confused. 3 multiplied by 4 is 12, then root 5, then minus 5 multiplied by 2 is 10, then root 5, plus 2 multiplied by 3 is 6, then root 5. So I'm having set of values that have root 5 in common. So the usual way, factorization. So here is going to be 12, then minus 10 plus 6 root 5. Okay, so when I simplify my brackets, I have to minus 10 plus 6, that is 8, then root 5. Hope that is understood. Now the last one, I think. So here I will need these figures so that we can understand better. I want to express 54 as a product of any of these. Can you just pick any of these? I think that's 9. That's 9. So I'll be splitting 54 into 9 multiplied by 6. Okay, I'll be splitting 19 into 9 multiplied by 10, and I'll be splitting 96 into 16 multiplied by 6. So here is 9, 9 is here, here is another 9, 9 is here, and here is 16. Okay, 16 is here. 54 as a product of any of these. I want to express 90 as a product of any of these. I want to express 96 as a product of any of these. Now, this is how I did it. Said 7, 54 split into 9 and 6. Okay, 9 multiplied by 6 is 54. So I'm able to get 9 here. Then plus 3. I am able to split 90 into 9 and 10, 9 by 10. Okay, why? I'm having 9 here. Then minus, this is 96. I'm able to split 96 into 16 by 6. Why? I have 16 here. Okay, so splitting them further, 9 by 6 becomes this, 9 by 10 becomes this, 16 by 6 becomes this. Okay, so that would translate to 7 root 9 multiplied by 6 plus root 9 multiplied by 10 minus 5 root 16 multiplied by 6. So that's going to give 7 multiplied by 3. Okay, then multiplied by root 6 plus here 3 multiplied by 3 from root 9. I'm getting this blue 3 from root 9, then multiply by root 10, then minus 5. I'm getting this 4 from root 16 multiplied by root 6. So simplifying everything I have here, I'm having 7 multiplied by 3, that is 21 root 6, then plus 3 multiplied by 3, that is 9 root 10. Here is 5 multiplied by 4, that is 20 root 6. I seems to have set of values that are not all the same terms. I'm having 21 with root 6, I'm having 20 with root 6, but I'm having 9 with root 10. So the first thing is I will need to collect the lag terms. So the root 6 terms in red are lag terms. Okay, I bring them together first. That's going to be 21 root 6, then minus 20 root 6, then plus 9 root 10 in white. The two values in red are lag terms, but it's not in the same term with them, so I cannot add this to them. So I simplify the root 6 terms, 21 minus 20, so that's root 6 itself, plus 9 root 10. Okay, I'm tired. So that's going to be 1 root 6, and 21 minus 20, that's 1 root 6, okay? That's 1 root 6. So I've told you, you don't write 1 root 6. Your 1 root 6 is root 6, then plus 9 root 10, okay? Here is the final answer. Or you can also write it as 9 root 10 plus root 6. Okay, they're still the same thing. So there is no any other way you can simplify this further. No, here is the final answer. You can simplify this further. So we have a final answer to be this. This is going to be all for today. Maybe it's somehow confusing, somewhere you don't get it. Post your question in the comment box. I'm always ready to attend to them. If you're new to this channel, do not forget to hit the like button, subscribe, and do share with friends. Okay, love you guys. Excellent in your mathematics and all your calculations. Goodbye. Do not forget to do your